On the first night, you just notice the sky looking wrong, too dark, too empty. By the end of the first week, coastlines around the world would be flooding and draining in unpredictable surges. Fishing industries would collapse. Shipping routes would become dangerous. Within a decade, Earth's tilt would start shifting. Seasons would become extreme and erratic. Some regions would freeze while others baked. And within a few thousand years, the planet that spent 5 billion years developing complex life would become hostile to almost all of it. This is the timeline of a world without the moon. To understand why losing the moon would be so catastrophic, you first need to understand what it's actually doing for us right now. The moon isn't just a pretty thing in the night sky. It's a 73 billion trillion kilogram anchor that's been shaping Earth since the beginning. Most scientists believe the moon formed about 5 billion years ago when a Mars-sized object slammed into early Earth. The collision was so violent that it liquefied the planet's surface and ejected a massive cloud of debris into orbit. Over time, that debris coalesced into what we now call the moon. And ever since that moment, the moon has been quietly running systems that make life on Earth possible. It controls the tides. It stabilizes Earth's axial tilt. It slows down our planet's rotation. And it acts as a gravitational shield that absorbs asteroid impacts that might otherwise hit us. Take away any one of these functions and Earth becomes a very different place. Take away all of them at once, and you get a cascading disaster that would reshape the planet entirely. So let's walk through exactly what would happen, hour by hour, year by year, until we reach the end of the timeline. The first few hours would actually seem peaceful. You'd look up at the night sky and see something humans have never seen before: a sky without the moon. It would be darker than any night in human history. The moon reflects a surprising amount of sunlight onto Earth. Without it, nighttime would be lit only by stars. For people in cities with light pollution, this might not seem dramatic, but for anyone in rural areas, the darkness would be genuinely disorienting. Animals that rely on moonlight for navigation would be thrown off immediately. Sea turtles use the moon to find their way to nesting beaches. Dung beetles use it to roll their balls in straight lines. Countless species of birds, insects, and marine life have evolved behaviors timed to lunar cycles. Within hours, ecosystems that have operated on lunar rhythms for millions of years would start breaking down. But that's nothing compared to what happens to the oceans. The moon's gravity pulls on Earth's water, creating the tides. High tide happens on the side of Earth facing the moon, and also on the opposite side due to centrifugal effects. This creates 2 high tides and 2 low tides roughly every 24 hours. Without the moon, those tides don't just stop, they transform. The sun also exerts gravitational pull on Earth's oceans, but it's much weaker than the moon's. Solar tides are only about 46% as strong as lunar tides. So if the moon vanished, we wouldn't have no tides. We'd have much smaller, less predictable tides driven entirely by the sun. This might sound like a minor change. It's not. Tidal zones are some of the most productive ecosystems on the planet. The constant flooding and draining creates unique habitats where land and sea species interact. Mangroves, salt marshes, and coastal wetlands all depend on regular tidal patterns. With tides reduced and destabilized, these ecosystems would collapse within years, and since coastal wetlands act as nurseries for countless fish species, the effects would ripple through the entire ocean food chain. Fishing industries that feed billions of people would be devastated. Coastal cities that were built around predictable tidal patterns would face flooding and erosion they were never designed for. But we're still just in the first weeks. The real changes take longer to manifest. Earth's rotation would start speeding up. Right now, the moon acts like a brake on Earth's spin. Its gravitational pull creates tidal bulges in the oceans, and those bulges create friction against the ocean floor. That friction gradually slows Earth's rotation by about 4 milliseconds per century. Without the moon's braking effect, that process would reverse. Earth would slowly start spinning faster. Now, this change would be too slow to notice in a human lifetime, but over thousands of years, days would get shorter. Eventually, Earth could spin fast enough that days might be only 6 to 8 hours long. Shorter days would mean more extreme temperature swings between day and night. Weather patterns would become more violent. Winds would intensify as the planet's faster rotation affected atmospheric circulation. But even this isn't the biggest problem. The real catastrophe involves Earth's axial tilt. Right now, Earth is tilted at about 23.4 degrees relative to its orbital plane around the Sun. This tilt is what gives us seasons. When the northern hemisphere tilts toward the Sun, we get summer. When it tilts away, we get winter. What most people don't realize is that this tilt isn't stable on its own. Without the moon's gravitational influence, Earth's axis would wobble chaotically over millions of years, varying anywhere from 0 degrees to 85 degrees. At 0 degrees, there would be no seasons at all. The equator would bake year-round while the poles stayed frozen. Weather patterns would become completely static. At 85 degrees, Earth would essentially be rolling around its orbit on its side, like Uranus. Each pole would face the Sun directly for part of the year, experiencing months of continuous daylight followed by months of continuous darkness. Neither scenario supports the kind of stable climate that allowed complex life to evolve. The moon acts like a gyroscope, keeping Earth's tilt relatively stable. Without it, the axis would start drifting within tens of thousands of years, and once it starts drifting, it doesn't stop. Scientists have modeled what this would mean for life on Earth, and the results are grim. Agriculture, as we know it, depends on predictable seasons. You plant crops based on when you know warmth and rain will come. If the axial tilt starts changing unpredictably, growing seasons become impossible to plan for. Civilizations that developed around agriculture would collapse. Migration patterns that birds and animals have followed for millions of years would become meaningless. Species that evolved for specific seasonal conditions would find themselves in climates they can't survive. Within a few thousand years, mass extinctions would accelerate. Within tens of thousands of years, Earth's biodiversity could crash to levels not seen since the worst extinction events in geological history. And we haven't even talked about the asteroid problem. The moon is covered in craters, thousands of them. Each one represents an asteroid or comet that hit the moon instead of hitting Earth. Now, the moon isn't a perfect shield. Plenty of objects have still struck Earth throughout history, but the moon's gravitational influence does deflect some incoming objects, and its massive surface area absorbs impacts that might otherwise reach us. Without the moon, Earth would face a slightly higher rate of asteroid impacts over geological timescales. Any single impact might not be catastrophic, but over millions of years, the cumulative effect would add up. So where does this leave us? If the moon vanished tonight, here's the realistic timeline. In the first days, you'd notice the darker nights and confused animal behavior. Tides would become irregular. Within months, coastal ecosystems would start collapsing. Fishing industries would struggle. Coastal erosion would accelerate. Within years, the ecological damage would cascade through food chains. Species dependent on tidal zones and lunar cycles would face extinction. Within decades to centuries, Earth's rotation would measurably speed up. Days would get shorter. Weather would become more extreme. Within thousands of years, Earth's axial tilt would begin drifting. Seasons would become unpredictable. Agriculture would fail across large regions. Within tens of thousands to millions of years, the tilt could reach extreme angles. Climate zones would shift dramatically. Mass extinctions would reshape the tree of life. The Earth that exists today is not inevitable. It's the product of a very specific set of conditions, and the Moon is one of the most important. Now, there's some good news in all of this. The Moon isn't going to vanish. There's no physical mechanism that could make it suddenly disappear. And while it is slowly drifting away from Earth, at 1.5 inches per year, it would take billions of years before that drift caused serious problems. By that point, the Sun will have already expanded into a red giant and swallowed the inner solar system anyway. So the Moon leaving isn't really on our list of concerns, but thinking through this scenario reveals something important about our place in the universe. We tend to think of Earth as a stable, self-sustaining system, but the truth is more fragile. The conditions that allow us to exist are the result of cosmic accidents that happened billions of years ago. A Mars-sized object hitting Earth at just the right angle. A moon forming at just the right distance. A gravitational relationship that stabilized our planet's behavior for eons. Take away any one of those accidents, and the story of life on Earth looks completely different. The Moon isn't just our nearest neighbor in space. It's a silent partner that's been making life possible since before life even existed, and now you know exactly what we'd lose without it. Subscribe if you want more videos that explore the science behind impossible scenarios. I'll see you in the next one.